Now silent. Okay. So I will also we have completed the attenuation coefficient of the cam vibration. Now we will use the initial factor about we will start forced vibration. Okay. Forced vibration. Now silent. What is forced vibration? So you can see that in damped vibration, what happened? In damped vibration, the amplitude decreases, right? So exponentially with time. So what happened? Ultimately, the vibration stops. But if you want that the vibration continue with the same amplitude, then what to do? We have to put a force. But what type of force? What type of force? That is the periodic force. That means after certain time we have to put a force such that the vibration continue. Okay, such that the vibration continue, and the amplitude remains the same. That type of vibration is called forced vibration. What is the example? Physical example. Follow where we put the periodic force such that the vibration or the oscillation continue. আজকে দোলনা চাপুনি দোলনা কি করা হয় তোমরা কি কল্পনা করছো যেমন বেন্ডারতে নিয়ে যাও কি করো তোমাদের যখন আসছে আপনার সার্টেন টাইম পিরিয়ড দ্যাটস দ্য টাইম পিরিয়ড তবে ইন্ডিয়া সেখানে আসছে দ্যাটস দ্য টাইম পিরিয়ড হলো 2 ঘন্টা ফোর্স ওকে দ্যাট ইজ দ্য ফোর্স after certain time we have to put a periodic force that is called the forced vibration. What is forced vibration? Write down. If an external periodic force is supplied SUPPLIED to the damped oscillator to overcome the loss of energy. The amplitude of vibration does not decay with time. the amplitude of vibration does not decay with time. The amplitude of vibration does not decay with time, and the particle will vibrate, and the particle will vibrate regularly under such periodic force. Regularly under such periodic force. Regularly under such periodic force. Good, sir. This vibration of the particle is called forced vibration. This vibration of the particle is called forced vibration. Now we have to find out the differential equation of the forced vibration, and we have to solve it. Differential equation of forced vibration. And its solution. Differential equation of forced vibration and its solution. Okay. So what to do now? Now, if you take a particle of mass m, okay, which is oscillating here, A, B. This is the nodal point O. Okay. Now, when the particle comes at the point B, then we put a periodic force. What is the periodic force? That is F0 e to the power IPT. F0 e to the power IPT. This is the periodic force. Therefore, IPT means I theta. I theta means cos theta plus I sin theta. After certain time of period, we put a force F0. যখন একটা ফোর্স কমপ্লিট হবে F0, আবার একটা কমপ্লিট হলো F0. Okay, that is called the periodic force. Okay. Suppose a particle of mass m. Suppose a particle of mass m executing damped harmonic motion. Executing, EXECUTING, executing damped harmonic motion. দেখো এখানে বললাম কি executing damped harmonic motion. That means the last case where the particle is oscillating. If there is no oscillation, we cannot put the periodic force. Last case, light damping, damped harmonic motion is subjected to to an external periodic force is subjected to an external periodic force F0 e to the power I pt is subjected to a external periodic force F0 e to the power I pt, where P is the frequency of periodic force, where P is the frequency of the periodic force. And F0 is the amplitude of the force. Amplitude of the force. Full stop. Let x is the displacement of the particle from the mean position at time t. Let x is the displacement of the particle from mean position at time t. Okay. Then what are the forces which is acting on the particle? X is the displacement of the particle from the mean position at time t. Okay. So now, how many forces are there on that particle? In simple rotating motion, there is only one force, restoring force. In damped vibration, there is two types of force, restoring force and damping force. And in the forced vibration, there are three types of force which is acting on the particle. Okay, what are those? Restoring force, which is proportional to the displacement, damping force, which is proportional to the velocity, and another is called the driving force. And the driving force is the F0 e to the power I pt, which drive the particle or which drive the oscillation. So why it is called driving force. We have the restoring force, damping force, and driving force. Okay. There are three forces acting on the particle. Number one, restoring force. Restoring force proportional to minus x. Number two, damping force. Proportional to minus dx dt. And number three, driving force proportional to equals to F0 e to the power I pt. Okay. Therefore, restoring force equals to minus c into x, damping force equals to minus b dx dt, and driving force F0 e to the power I pt. Therefore, the differential equation of forced vibration is, therefore the differential equation of forced vibration is m d2x dt2 equals to minus cx minus d dx dt plus f0 into the power I pt. Why it is plus? Because now we apply the force. Okay, so that the oscillation continues. So it is plus. It is not the negative. F0 into pi pt. Or m d2x dt2 plus b dx dt plus cx equals to f0 into the power I pt, or d2x dt2 plus b by m dx dt plus c by m x equals to f0 by m e to the power I pt. Okay. Or d2x dt2 plus b by m কত ছিল 2k dx dt plus omega naught square x plus f e to the power I pt. Okay, so this is the differential equation of force vibration. Differential equation of, this is the differential equation of force vibration. Okay. Where 2k equals to b by m, omega naught equals to root over c by m, and f equals to f0 by m. Okay. Now we have to solve this equation. Therefore, it helps. Again, means in the right hand side there is 0, then you have solved it. Now in the right hand side there is the function of t, time. So how you solve it? This is a second order first degree differential equation. This is the second order first degree differential equation. Its solution contains two parts. Its solution contains two parts. Number one, particular integral, and number 2 particular integral and number 2 complementary function. Complementary function. এটা সলভ করে যেটা ক্লাস হবে pi f করে। Now we have to solve this equation by these two types. After then we have to add the solution. Two solutions. Okay, take it. Number 1, for particular integral. For particular integral, let the solution is x equals to a e to the power I pt. A dash e to the power I pt. Then dx dt equals to ip a dash e to the power I pt. And d2x dt2 equals to minus t square a dash e to the power I pt. I squared ho jabe eta, I square means -1. Substituting this value in equation 1, we get. Substituting this value in equation 1, we get. Substituting this value in equation 1, we get. d2x dt2 minus t square a dash e to the power I pt. Plus 2k ip a dash e to the power I pt plus omega naught square a dash e to the power I pt equals to f e to the power I pt. From the both side e to the power I pt cancel. Is it a common now? Make it other. Or a dash minus a dash t square. It is the only a dash minus t square plus I 2kp plus omega naught square equals to f into IPT cancel हो जाएगा or a dash equals to f by omega naught square minus p square plus I into 2kp. A dash equals to this one. Equation number 2. A dash equals to f by this one. Now we put omega 0 square minus p square, omega 0 square equals to z cos delta and 2kp equals to z sin delta. So this is equals to a dash equals to, therefore a dash equals to f by z cos delta plus I z sin delta. So this is equals to f by z cos delta plus I sin delta কত হবে e to the power I delta. Equation number 3. Now what is z? From here how we get the value of z? Squaring and adding. Okay? Squaring and adding we get z square equals to omega naught square minus p square a whole square plus 4 k square p square. Sin square delta plus cos square delta equals to 1. Or z equals to root over omega naught square minus p square a whole square plus 4 k square p square. Therefore, a dash equals to f by root over omega naught square minus p square a whole square plus 4 k square p square into e to the power minus I delta. This is equation number 4. So we get the value of a dash. এখানে যেটা ধরেছিলাম x equals to ধরলাম না, let the solution is x equals to a dash e to the power ipt. So we get the value of a dash. This is the value of a dash. Therefore the particular integral is x equals to a dash e to the power ipt equals to f by root over omega naught square minus p square a whole square plus 4 k square p square e to the power minus I delta plus into e to the power ipt. তাহলে কত হবে e to the power ipt into e to the power minus I delta. So this is equals to f by or x equals to f by root over omega naught square minus p square a whole square plus 4 k square p square into e to the power I pt minus delta. Equation number 5. So this is the particular integral of the differential equation 1. Look here, the amplitude is A equals to F by root over omega naught square minus p square A whole square plus 4 k square p square. This is the amplitude of the vibration. Equation number 6. Okay, this portion is the amplitude, and that is e to the I again into I theta, that is cos theta plus I sin theta. Now the second one, for complementary function. Number 2. Hello. नाम क्या है? Now for complementary function. For complementary function, what's happened? For complementary function, the right hand side of the differential equation becomes 0. Okay, for complementary function, the right hand side of the differential equation becomes 0. For complementary function, the equation number 1 becomes d2x. The equation number 1 becomes d2x dt2 plus 2k dx dt plus omega naught square x equals to 0. Equation number 7. Okay. So we have already solved this equation in damped vibration for light damping. Okay. So for light damping, that is for k less than omega naught. For light damping, that is for k less than omega naught. The solution of equation 7 is x equals to physical c e to the power minus kt into sin omega t plus 5. Omega equals to root over omega 0 square minus k square. So this is equation number 8. So this is called the PI, that is a particular integral, and this is called complementary function, CF. Okay, so what is the total solution? Therefore, the general solution of equation 1 is, x equals to general solution of equation 1 is x equals to pi plus cf. Pi plus cf. So this is the pi and this is cf. Pi plus cf. So x equals to f by this one, f by plus c e to the power minus a t sin omega t plus phi. So this is the total solution or the general solution of equation 1. That is the fourth vibration. Okay. So you can see that in the first term, it is oscillating with the frequency 3, which is the frequency of the applied periodic force, and the second term is oscillating with the omega, that is the damping force. So what's happening? This part represents the damping force, solution for damping force, damped vibration. So what's happening? After some time, this portion completely stop or vanish, because that is the damped vibration. After some time, the damped vibration is stopped. So after some time, what's happened? The particle will vibrate with this one only. That is the frequency of P only. Because this will cut down. The second part of the solution, represents damped harmonic motion. Represents damped harmonic motion. After a small time, the vibration becomes negligible. After a small time, the vibration becomes negligible as its amplitude decreases exponentially. As its amplitude decreases exponentially with time. With time. Thus, after a small time, the first part represents the forced represents the forced sustained 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 oscillation, forced sustained oscillation whose frequency P by 2 pi, whose frequency P by 2 pi is the frequency of the applied periodic force. Okay, that means now the particle vibrates with the frequency of the applied periodic force. Hence, the solution of the force vibration is up to this one. Only this one now. After some time, this is the solution of the force vibration. Okay. But you can see that here e to the power ic minus delta. So I into I pt minus delta. That means cos pt minus delta plus I sin pt minus delta. Okay, then what solution you will take? এটা মানে কি? So this is equals to f by root over omega naught square minus p square whole square plus 4 k square p square into sin into cos pt minus delta plus I sin pt minus delta. That is the full solution. e to the power I যদি ভাঙি তাহলে একসঙ্গে তো দুটো হতে পারে না, cosও থাকবে sinও থাকতে পারবে না। কারণ কি cos curve কেমন? Cos curve is like this and sin curve is like this. দুটো একসঙ্গে অসিলেট করতে পারে না। Then what term we will take? It depends upon what is the value or what is the term we are applying. That means if the force vibration, if it is the applied force is F0 sin Pt, if the applied force is F0 sin Pt, then we have to take the solution this one sin Pt minus delta. And if the applied force is F0 cos Pt, then you have to take up to this one. Okay, it depends upon the applied force. Let's go. Now, if the applied external force, is F0 cos Pt, then its solution is the real part. Real part means this one is the real part of the solution. Up to this one. And if the applied force is F0 sin Pt, then the solution is the imaginary part of the solution. Okay. So This is the forced vibration. So this is the solution of the forced vibration, and the particle will vibrate in our forced vibration like this. In the next class we will study the amplitude resonance and the velocity resonance. Amplitude resonance and velocity resonance due to the forced vibration. Okay.